Okay, 6 is solving radical equations, okay? And there's basically 3 steps in order to solve radical equations that we're gonna focus on today. So, first step of, are we on 6 or 6 5? 6 5, thank you. I was like, wait a second, that doesn't sound right. Let me pull up 6 5, how's that? That might be good. So 6 5 is graphing square root and cube root functions. Okay. So we're gonna graph cube root and square root functions. If you notice, a square root function parent form is 0, 0, 1, 1, 4, 2. Okay, we would graph it, and we would graph just this portion here. Because the problem is, if we graph the negative, then it's not a function, yes? Because I can draw a vertical line through it and it crosses twice. So when we graph square root functions, we only graph this little portion here. It has a parameter, okay? It's gonna have restrictions on it. When we graph a cube root function, we get like an S-type figure, okay? 0, 0, 1, 1, -1, -1, 8, 2, -8, -2. Because I can take a cube of a negative, yes? Okay? Now, with that being said, we can add things to it. When we add something inside of our radical, it shifts it left or right on both a cube root and a square root function. When I add or subtract something on the outside, it shifts it up and down, okay? Which means if I have something added in here and on the outside, it changes this point here, this 0, 0, this starting point, okay? If I have something on a cube root added or subtracted inside and outside, it changes the turning point, okay, the center of my function. Okay. With that being said, I get this. It says graph y equals 1/2 radical x, state domain and range. Compare the graph with the graph of y equals radical x. What do you know about that 1/2 outside of that radical?
Doesn't that make it go squish?
Yes, it shrinks it.
Yeah.
Shrinks it. Okay, it shrinks the graph, okay? Because whatever I plug in, I'm going to then get stuff out. Let's see if this, I don't know why this board is not working. So basically, if I graph this parent function, what do I want? That's what, no, see this, maybe. Okay, so if I graph this parent function, oh, it's off. Then I'm gonna get this, and then I get 1, 1, right? And I get the parent function that looks something like this. If I graph the function of 1/2, okay? 1/2 radical x, that means if I plug in, I still start at 0, 0. And if I plug in a 1, I get 1 out and then 1 times 1/2. What's 1 times 1/2? Yeah, so my graph is at 1 and then 1/2, yes? Ugh, this is so not fun, I gotta sync it. If I plug in a 4, I get a 2 out, right? And then 2 times 1/2 is 1, so I get 4, 1. So can you see how this graph compares to its parent function? What does it do?
Squish.
It's shrinking by a unit of 1/2, okay? So you're gonna have to write that also for me. You have to tell me, you have to graph it and compare it, and then you also have to tell me in words that it's shrinking by 1/2 unit.
We're not allowed to say squish.
You're not allowed to say squished.
Okay.
Okay. What happens here when I have this -3 in front of the cubic function? What does that do? It flips it and what else? And it grows it. It grows it. Yeah, we're struggling with our words today. It flips it and it stretches it by 3 units. It flips it and stretches it by 3 units. So once again, my parent function is like this, right? When I plug in a 1, I get 1 out. When I plug this in, I get that out. My parent function is looking like this. Okay. My function now, when I plug in a 1, okay, you get a 1 out, but then you multiply it by -3. So you get 1, -3, yes? So 1, -3. And if I plug in a -1, I get a -1 out times a -3, so I get +3. And as you can see, this graph has now flipped and is stretching out. Okay, it's stretched out. I will figure out why this board's not sinking, because that looks horrible. So you're going to start by graphing stuff like that. What is your domain and range of a cubic function? How far does it travel on the x-axis? How far does it go this way?
All numbers?
All real numbers. How far does it go this way?
All real numbers?
Yes, cubic functions are always all real numbers, domain and range, period. Cubic functions, all real numbers, all real numbers. Now, let's talk about the one prior. Let's talk about domain and range of a square root function. Where does it start and stop on this one? Where does it start? 0, 0. So my domain is 0 to what? To infinity, positive infinity. Okay, what's my range? 0 to what? What's happening here? What quadrant is it staying in right now?
1.
Staying in 1, and in 1 everything is
Positive.
positive. So my range on that one would also be 0 to,
All
And
positive.
how about infinity? We just say infinity, okay? So my range is 0 to infinity. Now, if it had flipped, right? If this had had a negative in front of it, it would be 0 to negative infinity for my range, okay? My domain and range are gonna be specific on here because it's going to have a specific starting and stopping, specific starting point. Okay, the stopping point will be whatever continues on, if it's gonna continue on to negative infinity or positive infinity, okay? But when I do cubic functions, it's always all real numbers, all real numbers. I talked about the H and the K. We just talked about the A, how it stretches or shrinks, okay? H and K translates the graph horizontally or vertically, okay? So what is happening to this graph right here? It says -2, the square root of x minus 3 plus 2, okay? -2 square root of x minus 3 plus 2. What's happening to this graph? Flipped, stretched by how many units? Okay, what else? -3 and 2, what does that tell me?
It's gonna be all real numbers.
It shifts. Does it shift right or left 3? Right 3. And what about up or down 2?
Up to.
Up 2. Outside always stays the same, x is what's always opposite. So my starting point, instead of being 0, 0, is now what? 3, 2. So my starting point is now 3, 2, okay? We're gonna pretend like this is good. My starting point is now 3, 2. And so now I'm plugging numbers in here. What numbers can I plug into x? Can you plug something in less than 3 into there?
No.
No, because I can't have negatives in my radical, correct, in a square root. So if I plug in 4, I get 4 minus 3, which is,
One.
square root of 1 is, 1 times -2 is,
-2.
plus 2 is,
0.
so you get 4, 0, right?
Yeah.
Okay, so 4, 0. Now, should this graph be going down?
No.
Yes,
Yes.
you have that right there. So yes, it should be going down, okay? It should be. So that means that because it should be going down, okay, I am on the right track. Now, let's plug in something else that I can take. If I did 4 minus 3, I get 1. If you do 7 minus 3, you get 4. Square root of 4 is 2 times -2 is, And -4 plus 2 is -2, so you get 7, -2, right? 4, 5, 6, 7, 7, -2, and my graph looks like this. What's my domain? What's my domain? Where's your starting point? 3. 3 is my x part, okay? So 3 is part of my domain, and then where does it continue to?
Negative infinity.
Negative infinity, good, because it's coming down, okay? So 3 to negative infinity. And what's my range? 2 to what?
Negative infinity.
Also negative infinity. Oh, no, wait, this is not negative infinity. It's not negative infinity, it's positive infinity. Because my x, I'm not plugging in negative numbers, I'm plugging in positive numbers for x. Okay? So domain and range. Okay, cubic function, what do you know about this cubic function? Tell me some things that you can see from there.
It's going down 1.
It's stretched by what? By 3 units, okay. Stretched by 3 units.
Move down by 1 unit.
Down 1 unit, okay,
Right 4.
and left. Left 4.
How did it go left?
It's always opposite of what that is.
Oh.
Okay, so left 4. So my starting point, or my turning point for this one, right, is what then? -4, -4, -1, right? So this is where my graph is going to turn, yes? Okay, so now I plug in numbers and I get things out. Let's plug in, I'm trying to think what's numbers I can take a cube of.
9.
You can take a cube of 8.
Oh, wait, no, yeah, sorry.
Of 8. So let's put a +4 in there, okay? I put a +4 in, I have 8. Cube root of 8 is 2. 2 times 3 is 6 minus 1,
5.
so 4, 5, right?
Yes.
So something like right here.
Uh-huh.
Let's plug in, oh, how could I get something that's cubic on this side of the negative? Plug in -12 and you would get -8, correct? Yeah, so if I plug in -12, I get -8, so the cube root of -8 is -2. -2 times 3 is -6, and -1, so -7. So -12, -7, so pretend like this is like perfect, okay? It's over here. So my graph looks like this, right? Which it should curve and it should be spread out by a lot. Domain range, what is it?
Wait, is that supposed to be like that? Or
Yeah, it's a slide curve because it's gonna be stretched so much that it's
what about the bottom one? Is that supposed to be going the opposite direction? Or?
the bottom one goes this way.
Okay.
What's your domain range? What's your domain and range for cubic functions always?
Oh, all real numbers.
All real numbers. You should never miss that on a quiz or a test. Domain and range for
So
cubic.
cubic functions is the ones that has like both parts, right?
Cubic
Top and
function,
bottom.
yes, it's the one that has both parts, it has a cube.
Because the other one doesn't have like the back of it.
Correct. Those are the things you are working on today, domain and range of cubic and quadratic or cubic and square root functions, and you're working on graphing the two.